let's pick up where we left off yesterday. We were talking about the different conic sections. We had several examples, and we talked about how you can tell the difference between an equation that produces a parabola, an equation that produces a circle, an equation that produces an ellipse, and one that produces a hyperbola. So we've got those different examples right there. Again, we're familiar with the shape of a parabola. We've seen that what a quadratic does. The difference now is we're dealing with parabolas that can open either up or down, in which case the x is squared. If it's got a negative on it, it opens down. Okay, and then we can have parabolas, full parabolas that open either right or left. They're not functions. In fact, most of these are not functions. They're just relations. In this case, this would be a y that's squared. It would open to the right if there's a positive, open to the left if it's negative. We went through and we used the definition to come up with this. Again, if we've got this defined point, this given point right here, and we've got this defined line right here, these come from the definition. That line is called the directrix, and that point is called the focus. The focus is always inside the curved part of a conic section. Okay? This point right here, the one that's smack dab in the middle between the point and the line, that's the vertex. It turns out to be the vertex of the parabola. The way we set this up, just for argument's sake and to make this a little bit easier to understand, turns out that the vertex is at the origin, and then we go a units inside the parabola to get to the focus and a units outside the parabola to get to the directrix. That a is really important. It has a huge amount to do with what the shape of the parabola turns out to be, whether it's really skinny or really wide and all that sort of stuff. And what was that funny word that represented the distance straight across the parabola from side to side that goes right through the focus? Latus Rectum. Okay, let's all say Latus Rectum really loud, please. Okay. Okay. Thank you, Mr. Putin. Okay. So we went over all of those things yesterday, and we said, you can tilt it to the side, all that sort of stuff, and then we said, you can memorize a whole bunch of different formulas, or you can just realize, in order to be in a graph-friendly form, and we call this standard form. Are we having a good time there, Len? Wow. Okay. In order to be able to graph this and put this in this graph-friendly form, we call this standard form, and it's got to have a perfect square involving one of the variables on this side, and then we've got to have a coefficient out in front, and then a factored form of the expression with the other variable over here. So this one right here, because x is squared, it's either going to open up or down. The vertex is going to be at h comma k, and what I advised you to do, and please lock this away and don't make this mistake, when you go through and do this and you figure out where the vertex is, don't always grab the first number that's right here and the number that's right here and say those are h and k. Okay? You want to make sure that you grab the number with the x, that's h, so it's right here on this one, right here on this one. Grab the number with the y, okay, it's over here on this one and over here on that one. That's the vertex. If it's positive and x is squared, it opens up. If it's negative and x is squared, it opens down. If it's positive and y is squared, it opens to the right. And if it's negative and y is squared, then it opens to the left. Okay? So again, that nice graph-friendly form has a perfect square in it, a factored form with the other variable. So we can tell what the center of what the vertex of that parabola is. And then we just kind of go from there. And you've got some equations where you have to put it in that form and all that other sort of stuff. You also have some equations that say, come up with the equation of a parabola where the vertex is at the origin and the focus is at 0, 3. So let's stop and think about this for just a second. Okay, if I've got a vertex right there, and then the focus is at 0, 3, so vertex here, focus right there. Which way does this parabola have to open? It's got to open up. Which variable is squared? X is squared. Is it positive or negative? It's going to be positive. So technically, if I were to write out everything, because that's h and that's k, it would be x minus 0 quantity squared, then it would be y minus 0, and then right here is a 4 times, what goes right there? A 3, because 3 is a, it's the distance from the vertex to the focus or from the vertex to the directrix. So I'm going to put a 3 right here. So the easiest way to write this one is x squared 12y. That meets those conditions right there. If the vertex is at 3, 2, and the directrix is x equals 1, so let's stop and think about this for just a second. 1, 2, 3, 1, 2. So there's the vertex. And then it says the directrix is at x equals 1. So if it's at x equals 1, that right there is the directrix. Which way does this one open? It's got to open to the right. It's got to curve away from the directrix. It's got to be, so the focus would have to be in here. So that means this is h and this is k. Again, h is always going to go with the x. K is always going to go with the y. So that means y is squared. So I'm going to write y minus, what number am I going to put right here?
2.
I'm going to put the 2. Okay, the k always goes with y. Okay, we know this is going to be positive. 4 times something, and then this has got to be x minus h, so that's x minus 3. The only question is, what goes right there? What's a in this case? It's 2, okay? Because if this right here is, this point was 3, 2, we went over 3 to get to this point right here. We only went over 1 to get to the directrix, so that means the distance between those two x coordinates would have to be 2. That means a is 2. Remember, a is the distance between the vertex and the focus and the vertex and the directrix, because it's got to be smack dab in the middle of the two of those. So here's how we'd write this. Y minus 2 quantity squared, 8, and then x minus 3. Okay? This is probably the best way to write it. If you were to square this out, I mean, say you looked at your neighbor's paper and your neighbor had written this. Okay, that's kind of hard to tell what that would look like. It's much easier to look at this graph-friendly form and tell for sure, hey, I know this opens to the right, and I know where the vertex is and all that sort of stuff. Okay, are there any questions? Okay, let's do a couple more, just make sure we're all on the same page. So I've got this one right here. This is an x squared. What are my choices? Up, down, right, left? Up or down, because it's an x squared. And because it's negative, it's going to open down. Where's the vertex? Vertex is at 0, 0. Okay? Vertex is at 0, 0. And we know it's going to open down. Okay, if this right here is 4a, now again, we've taken care of the negative. We kind of already used that. So don't say 4a equals negative 6. The negative just indicates the direction. That number that's sitting there, that 6, it has to be what 4a is. If that's the case, what is a? 3/2. It'd be 1.5, right? So that means we're going to go up 1.5, and that's going to be the directrix. So I'm going to go ahead and label that. That's going to be y equals 3/2. I'm going to go down 1.5. That's going to be where the focus is. So I've got the focus right there. I've got the vertex right there. And then, unlike when we studied parabolas before, when they were just functions of x and stuff like that, and we had to say, okay, we've got the vertex, and then we go over 1, up 1 squared, over 2, up 2 squared, over 3, up 3 squared, and so forth. Okay? With these types of parabolas, we can really hone in on what the shape is just by figuring out what the latus rectum is. So the cool part is, how long is the entire latus rectum from one side to the other side? 6. So how far do I go in each direction? I go 3 in each direction. So I'm going to go 1, 2, 3, put a point right there. And I'm going to go 1, 2, 3, put a point right there. Now, I want to label each one of these points. I'm going to make this a little bit bigger so I've got something to draw here. Put arrows on the end. Okay, now the focus would be at 0, negative 3/2. Remember, the vertex was at the origin, so it's at 0, 0. I'll grab it. And you go ahead and label the endpoints of the latus rectum. So what are the endpoints of the latus rectum then? What's this one right here? Over 3 and then down the exact same amount. So you'll notice that each one of these points has exactly the same y coordinate. And this one's going to be back 3 and then down 3/2. Okay, everybody good there? Okay, if you label those 4 points and label the, 4 points and label the directrix, you're all set. Okay? Any questions? Okay, let's take a look at the next one. Cameron, which way does this one open? How can you tell? Okay, but if it's negative, it could open down, right? How do you know it opens to the left? Okay, so if the y is squared, that narrows down our choices to left or right. And because it opens to the left, it's going to be negative. So vertex at the origin. We've taken care of the sign. That tells us what direction it opens. 4a is the same as 4, so that means a is equal to 1. So I'm going to put a directrix right here and label it. So that's going to be x equals 1. I'm going to put a focus right here. And then how long is the entire latus rectum? So how far do I go on each side? Just 2. So I'm going to go up 2, and I'm going to go down 2, and I'm going to draw a nice little parabolic curve. Hopefully make it touch there. If not, I'm going to make that really fat. Okay, so this is going to be -1, 0. Vertex is 0, 0. And this point right here is -1, -2. And this one is -1, 2. Easy enough? It's not bad, right? Okay. Couple more. Let's take a look at this one. Okay, there's something slightly different about this one. Can anybody tell me what it is? Okay, the vertex isn't at the origin. That's one thing. What else? What's that? The y isn't squared, the x is squared, so our choice is either up or down, right? Okay, one other thing, yeah. Okay, the 4a is, careful here, the 4a is not really there, is it? Because we don't have this in factored form. So we want to factor this. There's nothing really to factor out. You can always factor out a 1. So what's stuck out there is a 1. So that means 4a is equal to 1. So that means a is equal to 1/4. So this is kind of a weird one. Everything here is going to be really close together. Would you write down where the vertex is, please? Vertex is at -1, 1. Okay, grab the number with the x and then grab the number with the y. There's your h and k. So -1, 1. So we are right here. There's our vertex. We know this opens up. How far do I go to get to the vertex and to get to the directrix? Only 1/4 of a unit, a tiny, tiny amount. So I'm going to go up 1/4. There's the focus. I've got the vertex there. And then the directrix is going to be right here. This is when I need a really skinny, fine point marker here. So this is y is equal to 3/4. That focus is at the point -1, 5/4. And then the entire latus rectum is only 1 unit long. So I only go half a unit in each direction. So I'm going to go half a unit over here, and I'm going to go half a unit over here. And what that does is, that makes a fairly narrow parabola, but it's actually a standard shaped parabola is what it ends up being. Okay? So I've got the focus labeled here. Let's label this point right here and this point right here. Remember, I went forward a half a unit, so that's going to be -1/2, 5/4. And this one right here is going to be back another half, so that's going to be -3/2, 5/4. Okay? So it's very tightly packed. All of the important features on this are really pretty tiny. Okay? Any questions? Okay, let's stop and think for just a minute. On this, I've got this blown up 300%. So this is 3 times bigger than it would normally appear. I've got a pretty fat marker here. You're probably not too bad on there. Is there something that we could change to make this easier to see all of these features? Change the scale. Okay, what could we do to change the scale? Make every tick mark. make every tick mark a fourth, and then we're all set. We could have gone over to here, up to here, and then we would have been doing points here, lines here, and then over to here and over to there. Would have been a lot easier to see spread it out just a little bit. Changing the scale would be a nice feature to do on that particular one. Okay, if you do something like that, you want to make sure everybody's clear on what you're doing. So make sure you label the axes, make sure you label enough points that everybody knows. Okay, any questions there? Okay, let's take a look at this one. Would you go ahead and do this one, please? Graph it, label all the points, make it clear you know what you're doing. Okay, before we go any further, where is the vertex? Okay, the vertex is at -3, 2. If you put 2, -3, you're grabbing things in the wrong order. Remember, you always have to look what's with the x, that's the h. Opposite of that is the h. Look at what's with the y, that's the k. Works that way every single time. How long's the whole latus rectum? 12, so you got to go 6 on either side, right? So that means I've got to go up 2, 4, 6, about right there. About right there. Correct? Got it? Okay, easy enough? Okay, these are not bad, right? Okay, you keep track of the focus, know how long the latus rectum is, know how to figure out what A is, know how to tell what direction it goes. Should be pretty easy. The H and K thing we're already very familiar with, just that one caution about these are going to be written in different orders, so make sure when you're finding H, grab the factored form with the X. When you find the K, grab the factored form with the Y, and you should be in good shape. Okay, any questions? Okay, let's take a look at the last couple. These last few problems, these are actually just a little bit different. These are not written in graph-friendly form, so we have to put them in graph-friendly form, and that graph-friendly form always has a perfect square in it. So if it doesn't have a perfect square in it, what do you have to do? You have to make a perfect square, which means, what's that phrase again? Complete the square. We got to complete the square. Okay? Now, if I said complete the square on the SAGE test or complete the square to get an A in this class or something like that, how many of you know absolutely for sure I know how to complete the square? I remember exactly how to do that. Okay. All right, that's what I was afraid of. Okay, so let's take a look at this. Here's how we complete the square. We're going to gather the x's together, and then we're going to put everything else on the other side. The reason we're going to gather the x's together on this one is because the x is squared. We're always going to have the squared variable on the left-hand side. So I'm going to do it over here, x squared minus 4x. I'm going to leave room to complete the square, and then I'm going to move everything else on the other side. So that's going to be a 4y plus 4. Everybody see what we did there? Okay, now, again, just everybody will remember this in just a second, but you cannot complete the square unless the leading coefficient, the one on the squared variable, is a 1. Okay, the way these are set up, it's always going to be a 1. Okay, if it's not, you could just go through and divide everything by that number. So if this was a 2, you could just go through and divide everything by 2 and you're all set to go. Okay, so the process for completing the square, once you have that as a 1x squared or a 1y squared, is you take half the middle coefficient. So if I take half of that, that's -2. I'm going to put a little circle around that because I'm going to use that again. Okay, and I'm going to square that. So I'm going to square that and I'm going to put it right here. So I added 4 to that side. If I add 4 to this side of the equation, I better add 4 to that side of the equation. And then the reason I wrote this down and circled it is this side is now a perfect square of that variable and that number right there. So this is now x minus 2 quantity squared. And then over on the other side, here's what I've got. I've got 4y plus 8. But I wouldn't want to leave it looking like that because I have to have this in factored form. So what do I do with the 4y plus 8? Take out a 4. So I take out a 4 and I'm left with y plus 2. And now it's in a nice graph-friendly form. I'm not going to graph this entire thing. We'll just kind of sketch this out really quickly. Where is the vertex? 2, -2 opens up. And what is A? A in this case is 1. Everybody good there? Okay, if you have those pieces of information correct, you ought to be able to graph this. So we're going to go to 2, -2, so right here. It opens up, so we're going to go up inside the parabola to get to the focus, down 1 to get to the directrix, and then this is 4 units long altogether, so that's what it would look like. Okay? And then you could label all the points, right? So you'd want to label the focus, the endpoints of the lattice rectum, the vertex, and then you would want to label this. This would be y equals -3. Everybody good there? Okay. Would you do part B? Go ahead and complete the square on that one. Okay, is this what you got? Is that it? Okay, if you got that, then we should be in good shape because graphing these from here on out is pretty easy. Opens left. Vertex. Okay, again, grab the x, so that's going to be a 1. Grab the y, that's a -1. Okay, and A in this case, bit of a pain, 1/4. Okay, because that number out in front there technically is a -1. That's going to be the same as 4 times A, so A's got to be 1/4. So this is another one of those. If we were going to graph this, let's go ahead and change the scale on this one so we've got a little more room. So this is going to be at 1, -1. So this would be over here and down here. Okay, so this is 1 and this is -1. It opens to the left, so I'd go 1/4 over here. So this would be x equals 5/4. We'll go ahead and label that one. The focus is right here, the vertex is right here, and then I go a half a unit up and a half a unit down, and this is what it would look like, and you should be able to label those points. Okay? Any questions? Okay, we good? Okay, this is great. You'll have some time in class to work on this. If you flip over the page, let me just point out, I have this sentence on each one of the notes for conic sections. When you're doing these, you're going to see lots of different types of problems. I've given you the basics, and we're going to take a look at a few different things right here. You're going to be looking at a graph and figure out what equation it must have come from. Be given an equation in a nice graph-friendly form, and you're supposed to graph it, which should be pretty easy. Maybe they'll give it to you in a not-so-friendly form, like these guys up here, and you have to put it in a form where you can tell where's the vertex, which way does it open, and all that sort of stuff, okay? And then sometimes you'll be given information about, hey, I've got a directrix here and a focus here, what's the equation? So they'll describe information, and you've got to figure out what the equation is. Or they'll give you a couple pieces of information, and then they'll say something like, it goes through this point. So it wouldn't be enough information to come up with the entire thing, but if you add a point to it and throw that point in the equation, then maybe you can figure out what the actual equation must have been, okay? So a lot of these require you to, this is what makes these kind of cool and thought-provoking is, you've got to put together a lot of the information that you've learned in your math courses in order to be able to figure out a lot of these problems, okay? Not a lot of them, some of them are a little bit on the tough side, okay? Challenging, I'll call it that. You got to think for a minute before they're going to sink in. So you've got some problems that are literally this easy. I copied these out of the book. This is problem number 5 and 6. This happens to be choices A and B that I've given you. 1 through 6, they give you 6 graphs and 6 equations, and they say match these up, okay? So the answers might be here, or they might not. You have to know what you're looking for in order to get this right. So let's take a look at this one right here. Okay, just looking at the graph, what behaviors or what do we know would have to be true about the equation? The y would have to be squared. That's the first thing we note. And it's got to be positive, okay? That's not going to work. There's no way this one can be matched up with number 5, right? Okay, let's take a look at this one. What can we tell just by looking at the graph? X has got to be squared and it's got to be positive, okay? So definitely not this one. Could it be this one? It could be. So let's maybe just check and see. Do we have enough information here to tell where the focus is? Like just by looking at the graph. Not by looking at the graph. You can't tell where the focus is just by looking at the graph. But let's say we think this is what the equation is. Okay? Now this is actually going to be easier because you've got all 6 choices when you look in the book. Okay? How long is the latus rectum? 2. Okay? What's A in this case? A in this case is a half. So if this was the equation, we should be able to go up a half a unit, about that far. And then how far would we have to go in each direction? We'd have to go 1 unit. So if I went over 1 unit and over 1 unit, does this look like it lines up pretty well? Okay, that's what I'm talking about, is piecing together the stuff you know about these parabolas and matching up the characteristics of a graph. Everybody got it? So I'm pretty sure B is part 6, but again, check the 6 choices that you've got on 1 through 6. Any questions there? Okay, take a look at problem number 48. It says, find the equation, then graph and label completely. Now, please read the instructions for each part because sometimes it'll just say, come up with the equation. Sometimes it'll say, come up with the equation and graph. On this one, it says, come up with the equation, graph, and label, okay? So it says the vertex is at -1, 2. So we know that's got to be H and that's got to be K. It tells us what the focus is. That's not really part of the equation, but it can help us figure it out. So let's think about this for just a second. -1, 2, and -1, 0. It does. So let's think about this. If I go back 1 and up 2 to get to the vertex, and I go back 1 and don't go up or down and I've got the focus, this is what I've got right there. I've already started graphing this. Just from those two pieces of information, I can tell a whole bunch about this. First of all, which variable is squared? Got to be x that's squared, okay? And in front of the other side has to be a negative. So I'm going to write x plus 1 quantity squared equals negative, and then I'm going to write y minus 2. Good there? How do I figure this out? It's going to be 4 times a, and what is a? Okay, in this case it's 2, because remember, if we look at the equation, a is the distance from the vertex to the directrix and from the vertex to the focus. But if I have the vertex and the focus, I can look at that and I can figure out what a is. So a in this case is 2. I'm going to put a 2 right here, or I'm just going to do this, -8. There's the equation, correct? And how do I finish graphing it? If I've got those 2 points, how do I finish off a complete graph of this parabola? Yeah, I could do the endpoints of the latus rectum. How far do I go in each direction on the focus? 4 units. So 1, 2, 3, 4. 1, 2, 3, 4. So I've got these points. Now, I think I mentioned this once before, but let me mention it again. I'm going to put the arrows on here. We can label those points. I'd go up here. I'd have the directrix. The directrix would be y equals 4. I'd label all these points, even though they gave them to us and all that sort of stuff. So this one would be 3, 0, and this one would be -5, 0. Am I correct about all that? What parts of this are the parabola? Is everything I've drawn on this graph, is everything the parabola? Nope. This is the only thing that's the parabola. That's it. The focus is a useful piece of information. It has something to do with it, but it is not the parabola itself. It's where all of those parallel rays, or there's parallel energy beams and stuff like that, that's where they would focus. The directrix helps figure out, well, it's got to go away from the directrix. It kind of wraps that around the focus. They're important pieces of information, but they are not actually part of the graph of the parabola. Okay? Important distinction to make. Okay? All right, let's take a look at number 44. Okay, all it says here is find the equation. That's it. So we look at the graph. We know a couple of things. Okay, we can look at it until we can tell what the vertex is. We can tell because of the direction it opens, it's got to be negative and y squared. Okay? So if that's the vertex, I'm going to be writing y minus 3 quantity squared. I'm going to write a negative, and then I'm going to write x minus 5. Now, how do I figure out what this number is? Okay, there are a couple things that I would do to make it easy. We could put a 4a there, right? We could put a 4a. If they had told us the focus was right here, we could just measure that distance right there, figure out what that is, and that would help us figure it out. Okay, we could just double that, go from side to side, and that would be the number that goes right there. But it doesn't say where the focus is on this one, okay? So what I can do here is, rather than put a 4a here, let's just put a b. So b is going to represent 4a. It'll make it just slightly easier to solve. If you want to put a 4a there, you can. It's just adding an extra number in there. How do I figure out what that number is? I've got almost the entire equation. I've got the vertex plugged in correctly. I've got the right variable squared. I know part of it's negative. Yeah. Okay, the problem is we're not quite sure that that is the endpoint of the latus rectum, but you're on the right track. This is the only thing we haven't used. What could we do with it? Okay, I mentioned, I think some of you are on the right track. I mentioned something yesterday that I said people forget all the time, and I reminded you of this earlier in the course. I said, if a point works in the equation, then it's on the graph. But don't forget, if this is on the graph, what has to be true? If you plug it in, it's got to work in the equation. So I can figure out what number has to go right here by plugging in 4 minus 3, quantity squared. This would be minus b, and this is going to be 4.5 minus 5. So this is going to be a 1 on this side. This is going to be a b, and this is going to, negative b, sorry. And this is going to be a negative 1/2. So what I've got here is 1 equals b over 2. So b has to be 2. The b is 2. It still has a negative in front of it, right? You with me there? Okay. Any questions? Sure? Okay. Let's see. This is the last one I've got here. Okay, so let's take a look at this one. Okay, would you read problem number 61, please? Okay, this is actually a three-dimensional parabolic dish is what this is. These are those paraboloids of revolution, okay? And what it's telling us is the receiver, the satellite receiver, okay, is 4.5 feet away from the vertex. And what they want you to come up with is find an equation of the cross-section of the reflector. Okay, now, does anybody have one of those old satellite dishes, or somebody in their neighborhood have one of those big satellite dishes? Okay. 20 or 30 years ago, people had satellite TV. They just had a dish that was the size of this desk on top of their house. Big, huge pole holding it up, and I mean, just pointing up there. Okay, it was pretty cool at the time. Okay. Now they've got just these little tiny ones, which is awesome. Okay. So, and this isn't uncommon, that it's big enough that the dish, the focal length of this, 4.5 feet out here. So you've got to have a little arm kind of holding that receiver out in front of the dish. Okay, 4.5 feet out there. Okay, so this is probably a realistic equation. Okay, look at this, and if you're going to figure out what the equation is, basically if we were to slice it straight down the XY plane, we're looking at this right here. Okay, so if I did it across the top, it's like slicing the bowl right in the middle. Okay, notice where they put the vertex. If you've got a choice, if they didn't tell you where to put the vertex, where's the best place to put the vertex? At the origin, at 0, 0. Okay, then you look at this and you notice, well, gosh, this is just like some of the other ones. This is a parabola that opens up. That tells me which variable is squared. I know what h and k are. All my job is to figure out, gosh, I just need to know what A is, and I can plug it in and I've got the equation. Okay? That's it. I'll leave that for you. Okay? Here's the assignment. It's page 782. Please have that done when you come to class tomorrow. You've got a couple minutes that you could get it started right now. Okay? See if you can get maybe the first 6 or 7 problems done. You ought to be able to do that. Bring your book tomorrow. If anybody sees Alexis, please tell her to bring her book. Okay? Bring your book. We'll turn it in tomorrow. We'll do ellipses tomorrow, then we'll do hyperbolas on Friday, and then that's it. Okay? All right. Any